We've started Unit 3. Guys have already explored the dead dudes. These are the men who have shaped our atomic theory, or what we think the atom looks like today. We don't really know exactly. We're pretty sure we do, but it's a theory because no one's seen the atom directly. We have seen it indirectly with models and special microscopes. But right now, after learning about all those men who came before us, let's go through what we think the atom looks like today. Okay, so the structure of the atom starts with a nucleus. This is that dense core where all the mass is. So in the nucleus is all the mass that we care about. Yes, electrons weigh a tiny, tiny, tiny little bit, but the percentage is so low. At this stage in the game, for you guys in high school, we're going to pretend that they have absolutely no mass because you are not a particle physicist. Okay, so in our nucleus, we have two subatomic particles, the protons and the neutrons, and then we also have electrons living in the cloud around the nucleus, and that's our third subatomic particle. Our protons have a charge that's positive, our electrons are negative, and our neutrons are neutral. Okay, don't think N is negative there, they're neutral. So these are our charges. Okay, so make sure you know those are our charges. And our protons and neutrons, protons positive, neutrons zero, are in that nucleus. So basically all our mass is in the nucleus. And then, as you've learned, there is a formula that we use to find the probability of where an electron might be, and we call that the electron cloud. So when you draw it, I want you to draw just these little squiggles. I don't want you to think that we know the electron orbits around the nucleus. That's not how it works, okay? And then we put our little tiny bitty electrons in here. Okay, however, this is just a hypothetical atom for you guys to see where things are. Now let's talk about if this nucleus was expanded to the size of a marble in tons. Okay, that's how much mass is in the center of an atom. And if this was true and we put this marble that we couldn't pick up at all in the middle of the Ohio State football field, our electrons would be all the way outside in the parking lot, and they'd be the size of a little flake of pepper. So although this model looks like things are close, they're extraordinarily far apart. That's why we say the atom is mostly empty space. And it contains this very dense nucleus that contains our protons and neutrons. So this is where all our mass is. Okay, right now everybody should pause this video and pull out your periodic table. I'm going to show you how to obtain this atomic information from our periodic table. So here I have beryllium right off the periodic table, and there's a number on top 4 and a number on the bottom 9.0. Okay, so periodic tables can differ. In Europe, they put this big number on top and the little number on the bottom. But what you need to know is the small number, no matter where it is always the atomic number. This is the element symbol. And our element starts with one capital letter. And that's important, capital letter. Okay, because every time I say a new capital letter, it means I have a new element. Some elements contain only one letter, some contain two, but my second letter is always lowercase. So, our atomic number, our element symbol, and this is our average atomic mass. And what is that the average of? It's the average of all isotopes. And we're going to get to that isotopes later in our notes. Beryllium actually can contain more neutrons. The atomic number here is always the number of protons and electrons in a neutral atom. Okay, atoms don't have charges. Protons are positive and electrons are negative. They have to be the same number, so they equal 0, so it's a neutral atom. Atoms of the exact same element always contain the same number of protons. So I like to say that protons are the identification of an atom. Okay? Now, I can have 4 protons and so many neutrons in beryllium, and the number of neutrons can change, and that's what an isotope is. Again, we'll put that in your notes later. Okay? Now, the average atomic mass. That's the average of all the isotopes. If I want the mass number of one atom, we're just going to round the average atomic mass, and for beryllium, that's going to equal 9. Okay? So what does our mass number tell us? Mass number equals, well, all the mass is in the nucleus, and the nucleus contains protons plus neutrons. So I can get the mass number, and then I can figure out how many protons and neutrons I have together. Well, I already know how many protons I have, which is 4, so my neutrons must be 5 to equal 9. So beryllium So the information I can obtain about beryllium from here, remember my atomic number equals the number of protons and the number of electrons in a neutral atom, and my mass number equals protons plus neutrons. So beryllium has an atomic mass of 9.0. That means my mass number is 9 and my atomic number is 4. Now if my atomic number is 4, I can right away put that I have 4 protons and I have 4 electrons. But how do I figure out the neutrons? Well, right here it says that my mass number, which is 9, equals protons plus neutrons, okay? Now, 9 equals protons, which is 4, plus question mark. So 4 plus what equals 9? 9 minus 4 is 5, and that's how I determine the number of neutrons. Now, this atomic mass can change based on which isotope we're talking about. So when you do your worksheet, make sure that you're not just pulling numbers right off your periodic table, because they give you some of these, and so you need to make sure that your math works out. Atomic number is protons and electrons. Protons plus neutrons is my mass number, or my rounded mass number. Before we get into isotopes, let's do one more together. We have magnesium, okay, and this information is right off your periodic table. Atomic number is 12, mass number is 24.31. That's my average mass, and that is 24.31. My mass number is just that number rounded, which is 24, and my atomic number is 12. What does this mean? Well, that means if my atomic number is 12, I have 12 protons and I also have 12 electrons. So how do I find my neutrons? Well, that is mass number equals protons plus neutrons. So my mass number is 24 equals protons, which is 12, plus question mark. So my neutrons must also be 12. Where do they live? Well, I have 12 protons here, and I have 12 neutrons here, and I have 12 electrons here in my electron cloud. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so this is what my atom looks like. I got all that information from my periodic table. Okay, now one thing to know is that my average atomic mass is in AMUs, atomic mass units. And those are a unit of weight that's so tiny I don't even want to talk about it. We'll never talk about it, so I don't really care that you know about it. We are going to talk about what that number means in a larger quantity, and that will be our next lesson coming up after we just talk about the atom. Okay, so the next thing we are going to talk about is isotopes. Isotopes. So what are isotopes? Well, first of all, isotopes are atoms that are all the same exact element. So we're going to talk about nitrogen. Nitrogen has several isotopes, but we're just going to talk about nitrogen 14 and nitrogen 15. First of all, when you see these symbols, they can be written in three different ways. Nitrogen 14, 14,7 nitrogen, or just 14 up here nitrogen. And what you need to know is my mass number is always the big number. Okay, and the atomic number is always the little number. So first of all, if I just see the dash, that's the mass number. And if you look at nitrogen, you can see 14 and 15 is really close to the mass, the average atomic mass. That's the mass number. When we see nitrogen written like this, you can see this is flipped from our periodic table, but the mass is always the bigger number. Why? Because the atomic number is protons and mass is protons plus neutrons. So the mass has to be the bigger number. It's two things added together, where my atomic number is just one thing. So let's look at these numbers and what they mean. First of all, I know that the most abundant nitrogen is nitrogen 14. This is a weighted average, so whatever my mass number is closest to, that's the most abundant isotope. And we are going to get into this math tomorrow, so you'll figure that out more tomorrow. Okay, so my most abundant is N14. Why? Because it's closest to my average atomic mass. If that was 14.99, nitrogen 15 would be my most abundant, but it's not. It's 1401. 14 is my rounded number. So let's look at nitrogen 14. First of all, that's my big number. That's my mass number. My atomic number for nitrogen, remember the atomic number, which is the number of protons, never changes. Okay, so if it's nitrogen, it has to be 7. When this number changes on your periodic table, and you should be looking at your periodic table now, every number is a new element. Not so of the mass. Okay, so if my atomic number is 7, my protons are 7 and my electrons are 7. How do I figure out my neutrons? Atomic number plus neutrons has to equal 14. 7 plus 7 equals 14, so that's a 7. Now, nitrogen 15, my mass number has changed. My atomic number can't change because my protons always stay the same, which means my electrons stay the same. So the only thing that can change is my neutrons. 7 plus what equals 15? 7 plus 8 equals 15. So isotopes. Are the same element with different number of neutrons. So we have a different number of a subatomic particle, which in turn changes our mass. Why? Because our mass is all made up of protons and neutrons inside that nucleus. This is where all my mass is.